The topic of this lecture will be the addition of carbenes to alkenes. A carbene is a carbon atom that has 2 bonds and 2 non-bonding electrons. Its formal charge is 0, but it is very reactive. The carbon center is electron deficient, making this a very good electrophile. Its lone pair of electrons make it a good nucleophile as well. Because it is a very good electrophile and a good nucleophile, it can add to the pi bond of an alkene to give a cyclopropane. The mechanism of this reaction looks very similar to the addition of the mercury catalyst to an alkene, because the mercury center is also electron deficient but contains a lone pair of electrons. The pi bond can attack the carbene, the electron deficient center, and the carbene can attack right back, forming the cyclopropane. Once the carbene is formed, the mechanism of addition to the pi bond is always the same, but the way that we form the carbene can change depending on the structure of the type of carbene we're trying to make. Let's look at some of those examples now. There are several ways to synthesize a carbene. We will talk about 2. The first uses a reactive compound called diazomethane. Diazomethane has the molecular formula of CH2N2. The structure of diazomethane looks like this. As you can imagine, with that many pi bonds and lone pairs, there is more than one resonance contributor that best represents the overall resonance hybrid of diazomethane. Pause the video and see if you can come up with another resonance contributor to this molecule. The other major contributor looks like this. When we treat diazomethane with heat or light energy, it leads to the dissociation of the molecule into a molecule of nitrogen gas and a molecule of methylene, a carbene. The mechanism for this reaction is a single step where the nitrogen gas leaves, leaving behind the carbene. Methylene is the simplest example of a carbene. The second method of synthesizing carbenes is through alpha elimination of haloforms. Haloforms are molecules with the molecular formula CHX3, where X is a halogen. This occurs because the proton of a haloform is very acidic. Let's look at the structure of this compound. The proton is acidic because the carbon is electron deficient. All of the halogens are more electronegative than carbon, meaning that we have bond dipoles pointing away from the carbon and towards each of the halogens. This means that the carbon is pulling on the electrons of its bond with hydrogen very strongly, making it much easier for a base to abstract the proton. Therefore, mixing a haloform with sodium hydroxide leads to deprotonation and formation of the negatively charged CX3 ion. This ion is unstable and quickly eliminates a halide to form the carbene. Now let's look at the mechanism for this process. In the first step, hydroxide ion deprotonates the haloform. Leading to formation of the anion. In the second step, a halide leaves, taking with it its bonding electrons to form the carbene. Next, we will look at some example reactions of carbenes with alkenes. First, let's look at what occurs when we treat this alkene with diazomethane. What we get as a product is the 6-membered ring fused to the cyclopropane. Now let's look at the mechanism. In the first step of the mechanism, diazomethane dissociates to form the carbene. Dissociation forms nitrogen gas and the carbene. The carbene then attacks the alkene, and the alkene attacks right back, forming the cyclopropane ring fused to the cyclohexane ring. Now let's look at the example of an alkene reacting with a carbene formed by alpha elimination. If we treat this alkene with chloroform and potassium hydroxide, we get the following product. Now let's look at the mechanism. In the first step, chloroform reacts with hydroxide ion. Hydroxide deprotonates chloroform to form the CCl3 anion. Next, loss of a chloride ion forms the carbene. Then the carbene adds to the alkene, forming the product. There is one last thing to consider with additions of carbenes to alkenes. This reaction is stereospecific. Because addition of the carbene to the alkene is a concerted mechanism, we see syn addition. So, for example, reaction of this alkene with diazomethane yields only a single stereoisomer of the product. And, for example, treatment of this alkene with bromoform and sodium hydroxide produces a single stereoisomer of the product.